Hi guys, welcome to this web series which is related to machine learning fundamentals. This is fifth episode today. We had in fact discussed in fourth one the linear regression and logistic regression implementation in Python. Very basic examples we had shown, and we'll be moving forward. We'll be taking a couple of more examples in this particular episode before we can go to unsupervised learning. Just kickstarting this, let me just present in front of you. This is the screen VS Code, so you can just see it. So this I have already created one file on this Python file, and I'll be writing the code one by one, and I'll be providing you. In fact, most of this is known already, so I'll be providing you the definition. First of all, from Sklearn, we are actually getting sklearn.linear model, and from there we are importing. So we are importing linear regression. So import and then linear regression. So it is giving linear regression, and this is the first thing which I am doing. And then I am importing numpy as well. So numpy as np. That I have imported. Now I'm importing matplotlib as well, because I am plotting actually certain graphs in this one. So matplotlib dot pyplot. So pyplot is here, and as a plt. So I will be putting it like this. And then what I am actually doing in this one, I am predicting. This is a linear regression problem in which I'll be predicting the house price based on the number of square feet. That means the house size which is there. Based on house size, I'll be in fact predicting the price of a house. So we are inputting the house size. So house size is the input. So I have put this comment here. In square feet we are putting it. So square feet, I am putting this house size, and then I will be having in fact x equals to np dot array, and I am just putting this array here. You can just see this. First value is, for example, 500, and then the second one is 800. So it is 800, 800. And then you are having third one as 1000. Okay, so that is 1000. And then fourth one is again 1200, and the fifth price which we are having, that is 1500. So this is the last one, and here I finish, and this I am putting x into this one, and then this will be generating the output. So output will be the price. So output should be the price in thousands. So price in thousands should be the output, and then we will be saying x equal, y equals, y equals np dot, then it has to be array. So array is there, and now in this array I will be putting the values. So this will be 1D. So that was 2D which we had given before. So that explanation I had given earlier as well. 200, 250, and then 300, and then 360. So these are some of the values which I am putting as the maybe it is 150, 150,000, 200,000, 250,000, 300,000, and 360,000 is the price of the house. So now I am creating a model. So I will put a comment here: create a model, create and train a model. So in fact, this is for the first time that I am writing this code line by line and giving the explanation. Prior also I had done the programs, but I was not giving. I had given the overall explanation for separate components. Actually, those programs were very small, so that was feasible for that. but here we know the meaning of most of the things we have written up till now. So some of the things later on we might have to discuss. So model we are choosing, as we know, linear regression, and model is equal to linear regression. So this is there, and after that model dot fit. So we are putting it into x and y. So x comma y, and then we are trying to predict. Now we will predict price for a new house. So it will be like this, and predicting price. So what predicted price, predicted underscore price. So now we are putting a different variable, equals model dot predict. So this is what we will be saying. Now we have to provide an input to this. So model dot predict. So inside this I will be putting, for example, 1100. So this is a new value which is not out of those which, so that is also that was discussed earlier as well. Before also we have discussed this. We are not giving exact, and the model is not, it's not actually the mapping of a thing which happens. It is not a mapping of a thing. So model is learning from the data which has been provided. So we will be providing a different value, and it should be appropriately, if it has learned from the data, it will be giving us output as per that, as per the trend which is there and what it has learned from the data. Now this particular thing we are giving that, we will be saying, for example, just for the sake of putting a message, we can say print, and then we'll be putting a predicted price for the price for 1100 square feet, because we are giving 1100 square feet as an input. House house equals or is the comma, then we'll be having predicted price. So predicted price we have already given, and this you will be putting as 0. So that's it. So this will be given. It is the first one which will be there. So okay, now yes, I think I had to just close it there itself. Okay, that's fine. It would have happened here as well, so I could have closed it here as well. That was not a problem. Okay, anyways, this predicted price we are doing here, and then the next step would be to draw. So some sort of drawing as well we will be just doing the plots, so that it will be giving us some graphical presentation. So draw graph. So what it is, so first of all I will be saying you plot x comma y comma label equals, so it equals actual data, right? So this is the first plot, and then plot plt dot plot x model dot predict. Okay, x, and then label equaled regression line. So this is just, it will be much more clear when it generates the output. Anyways, this is the plot, and plot dot scatter. So plt dot plot. Now plot dot scatter, again we will be saying that for 1100 predicted, the predicted price underscore price label equals predicted price. So we are putting predicted price. So we are putting actually the labels on one side, so that they will be appropriately giving numbers on the graph, and it will be having appropriate labels. So these labels will be there. So we are putting a plot scatter, and then you can just see when the output gets generated, you will just see plt dot title. So we are putting a title for this. So what will be the title of the graph? So that is house price prediction. using a linear regression. Okay, so this will be the title of the plot that will be drawn. And then plt.x label, so we'll be having x label and y label. So we can put x label to this as house size in square feet, house size in square feet, sq feet, and we'll be having plot.y label, y label will be price in thousands, so 200,000, 150,000, like this. So price in thousands, so price in thousands we can write down, so price in thousands. This is y label, x label, and y label, and then plot dot legend, so we'll be having legends on it. So then plot dot show, so this will be in fact showing the plot. If you just see, first of all, what we are doing is we are importing whatever we require for the program to run. Then there is an initialization which happens. In fact, this is a common skeleton kind of a thing where it is, and then when we have to give the code for predicting the model, that also remains almost similar. So predict price for a new house, so it can vary from one example to another example. So this is the thing which is there. And then one part which is the this draw graph, which we have written afresh, which is related to in fact the plotting of graphs. Somebody who's having a basic understanding of Python, and he would have done graphs as well, so this should not be something difficult to understand, because this particular web series is more focused on understanding the machine learning model that we have given all of that. But anyways, the related code which is there in Python, for that also I am providing some examples so that you can understand. So this is simple graph plotting. So we are putting different labels from different sides that will be now visible. So if I say run, I'm using Python debugger, okay, and this should be running. We'll see, it should not be giving any it has given the predicted price is 1100 square feet. The graph is also generated. You can just see this graph. So this graph is generated here. So it is showing, you can just see both the results. First, it is down in this terminal here. It's saying that predicted price 1100 square feet house is 273,000. So that is the predicted price based on whatever input was given. And if you just see whatever we plotted, so we plotted this graph, which is having in fact the X label. If you just see X label, what we had mentioned there was house size in square feet. So this is the X label. This is Y label, which is price in thousands. Okay, then we are having in fact legends are there. So legends are in fact here, and then we are having title is the house price prediction using linear regression. So that is what we had given. And then we have predicted this, we have plotted this, if you just say how we plotted this particular graph. It has been plotted on the 1100 square feet predicted price which is there, and the label is predicted. Okay, so that label which is there, that is predicted. It will be coming as predicted. So this is how this graph is. You can just see, and the full program which is coming on the left hand side, this output is generated on right side, and down out here predicted price which is for 1100 square feet. This we are giving from here itself. We are saying print predicted price 1100 square feet house is predicted price, which was predicted by the model here. So model is predicting it on the input in 1100. So very simple to understand. Predicted price, we are putting model dot predict. First of all, we put the model, we gave the data into it. Then we are saying that you apply the model on this. Model dot fit is xy. The xy data is given here, and then we are predicting using the model. We are predicting for one input which is 1100 square feet, what should be the price, and then we are printing that value, predicted price value here. and then after that we are plotting the graph. So we are putting XY label as actual data. That means it will be giving on this graph the actual data of X and Y. X is 500, 800, 1000, 1200, 1500. So exactly X is here 600, 800, 1000, and 1200 and 1400. So from this side it will be 150, 200, 250, 300 and 350. So from this side it is like this. So from both sides, if you just see X and Y, we are putting it that X should be like this and Y should be like this. First thing, we are XY label actual data we are putting there, and then we are plotting the X model predict and label regression line. So that is there, and then after that, actual data is in fact the one which is here. It is shown with the dots which are there, and then predicted point is this which is shown here. So on the graph as well, it is putting it exactly so that it is very clear that how this is getting. So I'm going to close this. These lines of code which are here, they are very much clear, and we shall be doing it in fact in the next this one more program, one more the one more episode, and that episode will be in fact taking logistic regression example, a similar kind of example which will be as complicated as this one. And we will be predicting in that a different example, because I had taken some student performance examples previously which were very basic. So we started from there so that you can get a know-how of that, and then we have moved ahead, and in fact we will be providing some complicated complex examples now, using different use cases. For example, this one which is related to price prediction of house. One parameter is given from here, and another is predicted from there, from the model we are training it, and then we are predicting a value. In the similar manner, we can have maybe a category of malware or not malware, or something like this. Some of the examples which will be given in logistic regression, which will be in fact finding the different in groups. In that, it will be putting it in one of the groups, and for that we are having example to come. So thank you so much for joining this, and I hope that it will be beneficial for you, and you will be just taking maximum benefit from this web channel which is there, and the web series that is there, and in fact multiple videos from here. Next episode will be episode 6, and that will be on logistic regression. So see you then. See you in the next episode. Thank you for connecting.